Hello students, welcome to Sourav Sir's classes. So for classes, mock test, study material, you can contact contact in the number given in the description. Okay, so let's start one of the problem from JEST Physics. Right, the problem states that a particle moves under a central force Fr is given by 1 k by r square into r cap. We need to show that the motion is confined to a plane and derive the effective potential, and next is to find the condition for the circular orbits and determine their stability. Okay, so these problems will help to clear the concept based on the angular momentum conservation, effective potential, stability analysis via second derivative test, and so on. And these types of problem also clear your concept to solve similar types of problem in your exam. Okay, so let's start to solve this problem in one of the easiest and fastest method, right? So to start with the solving, we have Fr is given as minus k by r square into r cap. The Lagrangian form is the Lagrangian is, we can write that L equal to half m r dot square plus r square theta dot square plus k by r. We know this expression from our theory. Next we need to find the angular momentum conserved. Now the angular momentum conserved, so we know that L equal to m r square into theta dot equal to constant, right? So we will use the effective potential. Use the effective potential. We have V effective into r equal to L square by 2m r square minus k by r. So for the circular orbit, we can write V effective by dr equal to, at r equal to r0, we have equal to 0, which implies L square by m r0 cube equal to k by r0 square, right? So which implies r0 equal to r0, it will go over there, so it will be L square m k. Okay, so this is the expression of the r0. So for the stability condition we have, for the stability condition, we have the double derivative should be greater than 0, means v square e double f by dr square at r equal to r0 should greater than 0 to have a stable orbit, right? So the motion is planar due to the central force. We have the motion is planar due to the central force and thus we have the circular orbit at r equal to L square by mk, and which is also stable. Right. Hope the solution is clear. So thank you.